Alright guys, what we want to cover today is something that you probably have already heard about. For those of you who haven't though, here's what we want to cover. Go ahead and do this in your science lab book, and we're going to title this Mole-to-Mole Conversions. That has got a little bit weird. Here. Go ahead and put the page number in the top right and our date today. Okay, so in mole-to-mole conversions, the whole point is that we can convert from one substance to another. That's the whole reason we've been trying to get you guys into moles. But what we're going to need first is a balanced equation. So in this first example here, let's go ahead and do the combustion of a gas called acetylene. That's H2C2, and we're going to react that with oxygen. And after it burns, we are going to produce CO2 and H2O gas. Now, the balancing of this equation, I'll leave that to a totally separate video. I think Mr. Jordan is going to help us with making a quick refresher video for that. So the balanced equation here would have a 2, a 5, a 4, and a 2. Now, what we are going to do in mole-to-mole conversions is we are actually going to have to convert from one substance, and it's going to have a unit of moles, to a different substance, also with the unit of moles. So that's a little bit confusing, but we'll try and make sense of it here. So in this example, what we'll have is something like 2.827 moles of H2C2. So this is how much of the acetylene gas that we actually want to burn. And let's see here. So this is how much acetylene we would like to consume via this reaction. But what we need to figure out is if this is how much acetylene I had and I want to burn all of the acetylene, I need to know the exact amount of oxygen that I need to pair it with. So here's what we want to figure out is we want to determine how many moles, let's erase that, how many moles of oxygen are needed. Okay, so it's actually pretty straightforward. We're just going to set up a t-table, and just as before, whatever number you're starting with, that's going to be your given, and that's what we're going to write down here. 2.827 moles of H2C2. And right underneath that, we always put a smiley face, or nothing. And here's where things get a little bit strange. We're actually going to have the unit mole over the unit mole. So this is where it gets kind of important that you guys actually get in the habit of keeping track of what substance we're talking about. So in this case here at the top, we're starting with moles of acetylene gas. And we're actually going to copy that unit just like we always do down below here. So let me go ahead and do that. I'm going to copy our unit of the moles. Let's see, there we go. Moles of the acetylene gas. Oops, I should not do that. Just kidding. And there. So that unit always gets copied diagonally down. And you really want to start keeping track of the substance, because otherwise you'll be extra confused, because on top here, what I'm looking for is moles of oxygen. So I'm going to have a different set of moles on top. So you have moles over moles. This is what we mean by the mole-to-mole ratio right here. So let me go ahead and write that. So right here, when you've got this, this is called a mole-to-mole ratio. Now we need to find out where it is that we get these values. We have moles of H2C2 and we have moles of oxygen, and I need to convert between them. And the only way that we can do that is if we use our balanced equation up here that dictates how things will react. So we didn't say this before, but a balanced reaction can actually kind of show you information one of two ways. the way that we were kind of introducing this initially was, if you read this, it was going to be 2 molecules of acetylene would react with 5 molecules of oxygen, and that would end up producing 4 molecules of carbon dioxide gas with 2 molecules of H2O. But when I introduced the whole concept of the mole, the reason that we kind of want to move away from this thinking is no one can really work on the order of magnitude of a single atom or just a couple of molecules here, like 2 molecules and 5 molecules. That's just way too small. So we want to start thinking this in terms of moles. So actually what this reaction, once balanced, tells you is that there's 2 moles of acetylene that will react with 5 moles of oxygen. And you'll end up producing 4 moles of CO2 and 2 moles of H2O. It's kind of like a recipe. Just like if you were trying to make a pizza, you know that in one pizza there is 1 crust, and then there's, a dozen pepperoni and several cups of cheese and some tomato sauce, and that yields you 1 pizza. Same thing here. Now, the kind of thing that we have here, though, is we don't have an exact 2 moles of acetylene. We want to figure out how much oxygen I would need if I had 2.827 moles. So here's where our mole-to-mole ratio comes from. It actually comes from these values, these coefficients here, where it says 2 moles of acetylene. So I'm going to copy this 2 here down below. Will react with 5 moles of our oxygen. So let's go ahead and do this calculation now. I've got our calculator here, so I'm going to take 2.827, multiply that by 5, and then I'm going to divide by 2, 7, okay, so that's going to be our answer there, 7.0675, and that's going to be in moles of oxygen, because these moles cancel with these moles. Now, looking at our number here, we have 1, 2, 3, 4 significant figures, so I need to keep 1, 2, 3, 4 sig figs, cut it off right there, and I'm going to round up. So the answer here would be 7.068 moles of oxygen. In order to react these 2.827 moles of acetylene, I would need exactly 7.068 moles of oxygen. And that's kind of your recipe in a way. If you were actually to do this reaction and you knew this initial quantity, then you would use the calculation we're doing here to figure out how much oxygen you would need to have. Of course, the moles number here is not where you'd probably end this. You would go 1 step further and you would actually convert this into grams so that you could measure this out in maybe an easier way. Alright, I think that's enough for this example. If you need to, go ahead and watch the subsequent video that has another example.